So why don't we have active physics? Well, this is because that's the way it's always been done. Well, why don't we have physics first? Because that's what, no, physics is last. That's the way it's always been done. Well, you know, we make these things up. Student attitudes. Well, when you try to have 100% of the students take physics instead of the 25% who presently take physics in America, you're going to have students, as we talked about at the beginning, who have experienced less success. You're going to have students who present class management issues. You're going to have students who don't buy into the system. What do I mean by that? Well, when you deal with the top 25%, no matter how bad school is, they really believe that if they go to school and do well, they'll go to college, they'll get a good job, and everything will be good. They actually believe that. I believe. We have a whole bunch of kids who have no modeling of that and don't believe it. They look in their neighborhood and they don't see anybody who that's worked for. Why should they believe it? They're not buying into the system. They haven't succeeded, and most of the people they know, by the time they're 22, have either been shot or in jail once, and most of the adults don't have jobs. How do we convince them? But this is the problem we have, the challenge we have, the excitement we have when all of a sudden we get kids excited about physics who would never before have gone near physics. Because physics, when these kids in 9th grade say they're taking physics, and there are kids in the next school district saying, physics? Physics is for the brainy kids. I said, no, we're taking physics. No, I'm taking physics. They feel so good because well, I'm taking physics. Physics has that mystique. Let's use it. You know, maybe when everybody's taking physics, everybody's done, and the world's a better place, it won't have that mystique. And then we won't feel so special, and people won't say, you teach physics, you must be smart. But you know what? I'm willing to risk that if, in fact, as a society, we can get better. But right now, woo! To give kids that, you're taking physics, whichever, whoa. Physics, it's tough for us, and it's tough for them, but that should not stand in the way of us doing it. It's easier to teach the top 25% of kids. Yes, I agree, it is easier. It is easier to teach kids who don't have special needs. It's easier to teach kids who show up every day. It's easier, but the success. I mean, you teach physics first. You know, I've taught a wide range of kids, and they like school, they like this. But you get kids who have never before succeeded in school, and you change their lives, unlike the kids who are always good. And they know it, and they respond to you that way, and it's really the best feeling you can have as a teacher. So let's talk about this 1968 study as we close here. The Pygmalion in the Classroom study you've all probably read about. That was where kids were chosen at random and told, and the teacher was told, these kids are unbelievable. Given tests, they are just gifted. These kids, not so good. And what happened is these kids succeeded and these kids didn't, even though they were randomly assigned. Now, another important part of the study was not only expecting the group to outshine, they did, but the children who did not act according to the expectations were viewed less favorably. So, if you, as the good, gifted group, and you aren't pulling your weight, it's like, come on, I know you can do it. You're not, no, you're supposed, I've heard about you. You have to. On the other hand, when you were shining and doing really good stuff, I was like, you know what, stick to page 23. I don't like you going ahead to page 35. That also happened. When the expectation was they couldn't do it, the teachers were upset when they could do it and squashed the kids. It's scary, but that's part of human nature. You know, I've had teachers tell me, oh, I can tell you what kids will get in June after the first 3 weeks. How dare they say that? How dare they say that? So, and then of course we have the American problem, which is wonderful, is that most people say, oh, I'm good at math. I'm not good at math. I'm talented in math. While everybody else in the world says, well, I work hard in math and therefore I get a good grade. Everybody in America is like the talent. So we have that problem also. These are the 3 key expectation measures. Physics first. This is important. You can do it. And I won't give up on you. Those are the messages every day. And all of a sudden you see kids who have never succeeded succeeding even in physics. So they learn language, they learn how to read. Physics is not harder than learning how to read. I mean, that you can take these little symbols and, you know, these curves, if I write in script, you can read. It's amazing that we can decode. Anybody who's ever looked at Farsi or whatever, you look at it and say, people can read that? But people can. So I love this reform, don't speak from reform. We have enough problems already. So here it is. Change decisions. You have the administrative perspective, which is tough. You want to go to physics first. 100% of the kids taking physics. Oh, we need a lot of books. That's going to cost a lot of money. We have to schedule classes. This is a problem. What are we going to do? That's how administrators look. Teachers. Who's going to teach all? We don't have enough physics teachers. What are we going to do? Well, we can't let people take physics because we don't have teachers. What materials are available? What kind of professional development are you going to do? What about this class schedule? What will I be teaching? But from the student perspective, is what we're presently doing when we take 25% of the kids, is that optimal? What can we do to improve the program for all students, and how can we provide what's best for students, all students? What I'm saying is describe what's best for the students, and then that's the gateway or threshold decision. Then you entertain the administrative and teacher concerns. Then we figure out how to get the physics teachers. Then we have the professional development. Then we find the money. But you start off by saying, let's do this. If there's room for improvement, we must change. So I love this because we're all science people. Every day, you know, in chemistry, you take a clear liquid, a yellow precipitate. The next day, clear liquid, yellow precipitate. Next day, clear, yellow precipitate. And it's like, no, I want blue. And we know as scientists, no, that's what we like about science. It's always yellow. Except without teaching. Oh, next year's going to be better. Why? Oh, I'm not going to change anything, but the kids will be better. You throw a ball with a specific angle, it lands in the same place every time. But in teaching, we think, oh, I'm going to teach the same way, and 100% of the kids will come now. No, they're not going to come. They've told you, they're not coming. You teach physics this way, 25% of the kids, all you're getting. Okay. Who's this? No, it's Galileo. Galileo. Why did Galileo get in trouble? What is it? Why did he get in trouble? The Earth goes around the sun. That was a big one. The Earth goes around the sun. That was actually only part of the trouble. He was friends with the Pope. He was a pretty famous guy. The Earth goes around the sun was part of his problem. Another part was he had the church character in his book called Simpleton. That was another little problem. But the big problem, the one that got him, was not the Earth goes around the sun, not the Simpleton reference, but he wrote the book Two World Sciences in Italian, not in Latin. And so what's the problem with writing it in Italian? Everybody can read Italian. Latin, only a few people can read. That's our new rallying cry. Let's finish what Galileo began, physics for all. Thank you.